welcome you all in this presentation related with the subject fundamentals of surface engineering. And you know that we have talked about the various aspects related with the fundamentals of the wear mechanisms and then methods which are used to modify the surfaces for improving the surface properties and enhance the tribological life. And after the modification of the surfaces of the substrate for enhancing the tribological life, it is important that those modified surfaces are also characterized with regard to the various properties such as the soundness, the depth of the modified layer, the mechanical properties and metallurgical properties and their tribological properties. So, you know that we are now talking about the characterization of the modified surfaces, and the main purpose of this chapter is to find out the values of the various properties of the modified surfaces so that we can take suitable and well informed decision about the suitability or applicability of the modified surfaces for the target application. So, basically we decide how based on the characterized values of the modified surfaces, decision is taken whether the modified surfaces will be fit for a given application or not. So, under this we have in the previous presentation we have talked about the one method of the depth or thickness of the modified zone. So, under this we can use the variety of the methods, and one method we have talked that was about the weight method, and apart from that the other indirect methods are like hardness testing or the microstructural variation or the compositional variation. So, these are the indirect methods, these three are the indirect methods. And in case of the weight method, we have to take the weight of the sample before and after the development of the modified surfaces, and any increase in weight is attributed to this modified thickness of the modified layer. So, in those methods where additional layer is applied, additional layer of the material is applied, this weight method is found to be more effective. Like say on the surface of the substrate we apply a layer of the material. So, we have to take the weight of the material before applying the layer of the material, and after we have to take also the weight of the component or the substrate after applying the layer, and difference of these two is used to see is considered or is attributed to the weight of the layer applied, weight of the material applied in form of layer. And now this weight is used for indirect calculation of the depth or the thickness of the modified zone, and for that purpose basically we calculate if we see this modified zone in the top view, and if this modified zone is over this area, then what we will see, width of this modified zone is say B, and the length of the modified zone is L, density of the material which is applied is rho, then rho into B into L into B into say average thickness about which we do not know. So, this is the value to be obtained, and the product of these three will be giving us the volume and multiplied by the rho. So, this will give us the weight. So, the T can be obtained from the delta W divided by L into B into rho. So, this will give us the average thickness of the layer which is applied onto the surface of the substrate. This is one method. There are other two methods also which are used for measuring the thickness of the layer which is applied, and these are like indentation method, and the second one is the ultrasonic method. So the principle of the indentation method is very simple. Like, this is the substrate over which we have applied a thin layer of the coating, or a layer of the material has been deposited. Then we apply, we develop one indentation using suitable ball on the surface of the on the modified surface. And in this case, what we do, like the ball of the large diameter, like 25 to 30 mm, 25 to 30 mm ball diameter is used to develop this indentation, and then the dimensional measurement of the indentations are used for calculating the thickness of this layer which is applied. So if we see, this is the surface indentation of the modified zone, and this is the indentation of the substrate, like this. And then we determine the values like y from 1, and this is the x, this is the another value. So these two values of the x and y are used for calculating the thickness along with the diameter of the ball which is being used for developing the indentation. So thickness of the coating, which is thickness of the layer which is applied in this indentation method, is obtained from the x multiplied by y divided by d. So this gives us the approximate value of the modified zone. This is the method which we can see here. In this case, this is the substrate, and this is the thin layer of the material which is applied. A ball of the large diameter, like 25 to 30 mm diameter, is applied, and suitable load is applied, so indentation is made onto the surface. Since the modified surface, the layer of the material which is applied at the surface of the substrate, that will have the different properties than the substrate. So accordingly, the indentation may vary significantly in these two cases, and then these dimensions are measured in terms of the diameter of the indentation at the surface of the modified layer, and this is the diameter of the indentation at the substrate. So this is the diameter of the indentation at the surface of the substrate, and this is the diameter of the indentation at the surface of the modified layer. And once we are able to get these two values, we can easily obtain the value of the y and x, and this y and x are used to calculate the thickness of the modified layer, which is obtained from x into y divided by d. This is how it is obtained. Now we will see the another method of the measuring the thickness. This is called ultrasonic testing. In case of ultrasonic testing, the ultrasonic vibrations are transmitted into the modified surface, and it uses the typical property or one very unique property of these ultrasonic vibrations, that these can penetrate into the metallic component, but these get reflected from the interfaces of mediums. Like, if there is a change in medium, here we have air, this is the metal X substrate. So as soon as the vibrations move from the air to metal, it comes across one interface, and these are reflected. Similarly, if the vibrations are being transmitted and and these are transmitted into the metal, as soon as these come across any defect, then then there will be one interface will be formed, and this interface will be between the metal to air. In this case, the interface was between the air and the metal. So whenever one change of the medium takes place, one interface is formed and the vibrations are reflected from that interface. So this unique characteristic of the ultrasonic vibrations is exploited in the thickness measurement. So what we do, we use ultrasonic vibration probe, which is applied onto the surface of the modified layer like this. This is the layer which is applied of metal B, and this is the metal S in form of substrate. Then when the vibrations are applied, these are applied onto the modified component through the use of the suitable liquid, so that there is a minimum loss of these vibrations and these get easily transferred to the component. So the vibrations are transmitted through the liquid, which is mostly in form of oil or water. This is called coupler. It helps to connect the probe with the surface of the component or surface of the substrate or the modified surface. When these vibrations reach to the surface, they will be initially reflected. So these reflected vibrations we can see on the oscilloscope in form of very strong peak like this, and then these will be transmitted through the modified layer, and then they will be coming across one interface between these two metals, which is in form of like say B and S. So again these are reflected, and then final reflection will be coming from the another side, where there is a change in medium from the substrate metal to the air. So we will be getting in this case these three peaks. So this last peak is corresponding to the reflection of the vibrations coming from the bottom side surface of the substrate and air interface. The first and strong peak is coming from the air to the modified surface metal interface, which is also a strong piece. Then there will be one weak peak reflection which will be coming from the modified means the material which is applied from the interface of the coating and the substrate, or the layer which is applied, interface of the layer of the material which is applied and the substrate. So the spacing between these two is used to characterize the thickness of the layer which is applied, and the spacing between these two peaks is used to characterize the entire thickness right from the modified zone to the bottom of the substrate, and this distance is used to characterize the thickness of the substrate. So in this case basically we are transmitting the ultrasonic vibrations at the surface. So from when these are applied, initially these will be reflected back from the surface itself, and a part of them will be transmitted in the metal, and as soon as they come across to the lower interface, again they will be reflected back, and if there is any defect or the interface, then we will be getting the third peak as well. So on the oscilloscope basically, if there is no interface and there is just the one substrate layer, so vibrations will be reflected back from the top, and then vibrations will be reflected back from the bottom, and these two will appear as a strong peak from the top and the bottom. These are the two strong peaks corresponding to the peaks from the top surface and the bottom surface, and this distance will be indicating the thickness of the substrate. But if we apply one coating like this, then again one interface will be formed and will be getting additional peak here, and that will be indicating the thickness of the modified layer or the layer of the material which is applied onto the surface of the substrate. So, this is what we can see here in the next diagram, like when the ultrasonic vibrations probe is applied to the surface of the component, it will be applied through the coupler, it will be these vibrations will be transmitted. So, initially it will be reflected from the top surface. So, this peak is corresponding to the top surface, and then another strong peak will be getting due to the reflection of these vibrations from the bottom surface. So, this is corresponding to the bottom surface, and if there is a layer of the material which is applied, then we will be getting one additional peak from the in between, and that will be suggesting the presence of the interlayer. So, the surface peak and the interfacial peak between the layer of the material applied and the substrate. So, that interface will be giving one additional peak in between, especially when there is no other discontinuity, and if there are discontinuities we can get number of other peaks. So, basically ultrasonic vibration method gives us the direct reading of thickness of the coating or the modified layer which is applied. And now we will see. So, after the thickness measurement, now we have to see that whatever the modification has been carried out at the surface of the substrate, that modification is perfect, or the modified zone which is formed is sound or not. Sound means whether it is free from defects and discontinuities or not, in form of, like, say, there may be pores, there may be cracks, there may be inclusions. So, defective modified surface layers will be leading to the increased tendencies for easy crack nucleation, their growth, and premature fracture, higher metal removal rate, higher wear rate. So, this will not be leading to a good situation, because the defective modified layer, if there are like defects in form of cracks here and there, pores in the modified zone, or inclusions of the foreign material or impurities, then these will be acting as stress raisers, increasing the stress concentration. Increasing stress concentration will be simply leading to the easy nucleation and growth of crack, increased wear and increased corrosion tendency of the material. So, in that case it may be unfit, unsuitable for those applications. So, all the modified surfaces should be assessed for their soundness. So, integrity and the soundness testing of the modified zone is performed using various methods, and it includes like dye penetrant testing. This is primarily used for assessing the surface discontinuities which may be there in form of surface cracks or open pores or the blowholes which are present at the surface. Then we have the magnetic particle test. Magnetic particle test is primarily used for magnetic materials to assess both surface defects and subsurface, but these are not very deep. So, we can say near surface defects can also be assessed by the magnetic particle test. These may be in form of like say pores or cracks or inclusions, etc. Then there are other methods like ultrasonic testing and X-ray testing. In case of in other two methods, we have seen they are primarily used for assessing the surface discontinuities, while these two methods are used for primarily used for assessing the subsurface or internal discontinuities. For example, if the modified layer at the interface has some kind of the defects, poor bonding, then all those cannot be detected very effectively using the other two methods like DPT and MPT, but these can be detected easily by the ultrasonic and X-ray testing. So, the defects which are present below the surface in form of cracks, poor bonding, inclusions, etc., these can be detected using the X-ray and ultrasonic testing methods. Now, we will see some the basic principles associated with these processes. So, in case of the dye penetrant test, if the surface having the discontinuities, in that case we apply a very thin, low viscosity, low surface tension liquid having the dye is sprayed over the surface. So, this is sprayed in this form. So, the dye which is there with the thin low viscosity liquid being sprayed over the surface. So, these minute and fine discontinuities present at the surface will be sucking the liquid by the capillary action, and once the liquid with the dye is sprayed over the surface, after some time it is wiped out, it is removed. So, this is the case when all the dyes present at the surface has been removed, and the dye with the liquid which has been sucked is left in the component. Thereafter, we apply one developer. So, developer may be in form of like say chalk powder or talc powder. So, that is sprayed over the surface. So, this will be this developer will be absorbing the liquid, and since the liquid is having the dye, so it will be leaving behind the stain in the developer, and wherever the stains are present, whatever is the extent up to which stains are present, that will be indicating the location, the size and the type of the discontinuities present at the surface. So, since the penetration of the thin liquid into the discontinuities is mandatory for assessment of the discontinuities in this method, and that is why this method cannot detect the discontinuities which are present in the subsurface zone. The magnetic particle test is the another method. This test simply lies on the principle is based on the principle like all the magnetic materials having the north pole and south pole, and magnetic lines will be moving from north to south like this, and if there is any discontinuity, then again it will be forming two poles, and in that case we know that these lines of the magnetic flux will be moving more effectively through the metals. But if there is open if there is a pore or if there is a crack, then again it will be forming the 2 poles, and wherever the defects and discontinuities are present, the leakage of the magnetic flux start from that area, and this leakage of the magnetic flux will be leading to the this leakage of the magnetic flux will be leading to the formation of the additional the fields here, and this aspect is exploited to detect the location wherever the discontinuities are present. So, considering this one in mind, like say this is the component having the discontinuities, it is magnetized either using the permanent magnets or electromagnets. So, obviously the north and south poles will be formed, and in this case whatever the locations are having the discontinuities, from there the leakage of the magnetic flux will start and it will be forming the 2 additional poles. Now, once the component to be checked, like this is the component having discontinuity here, so it will be magnetized using the current flow of current or using the permanent magnet. So, here will be having the 2 additional poles and there will be leakage of the magnetic flux. So, after the magnetization we sprinkle the magnetic powder particles. This is spread all over the surface of the substrate or the modified surface. Wherever there is a leakage of the magnetic flux, these magnetic powder particles will be attracted towards that location and they will get piled up. So, like after magnetization of the component having the defects, when we sprinkle the magnetic powder particles, these will be getting piled up at the locations wherever there is leakage of the magnetic flux. So, depending upon the intensity of the pile up and the location and the extent up to which this pile up is taking, means whatever is the length up to which piling up is taking place, that will be indicating the location of the discontinuity, size of the discontinuity, and so this is how we will be able to detect the fine cracks present at the surface. If the discontinuities are present below the surface, in case of the magnetic particle test, very hazy piling up of the powder particles take place. So, very hazy and a little bit piling up of the particle at a particular location suggests that discontinuities are present near the surface layers, not at the surface layers. Now, I will summarize this presentation here. In this presentation, basically I have talked about the 2 additional methods of the thickness testing and the 2 methods of the soundness testing. Soundness testing is important to see that how what is the soundness of the modified zone, whether they are free from the defect and discontinuities or not. Other 2 methods of the soundness and integrity testing I will be talking in the next presentation. Thank you for your attention.